Okay, now we're tackling 2.4, which is systems with linear equations by substitution, which ironically I would have done substitution first prior to doing elimination method. It's just the way the textbook is written. So in this one it says, solve the system by substitution method. You decide which equation you want to substitute into the other. The best way to go about these type of problems is look for an equation that already says x equal to or y equal to. Since this one says y equals, this is the one I'm going to use for substitution. You take your other equation, x plus y equal to 5, and you're substituting this into the y position. So I'm going to write x, and in parentheses, I put parentheses because I'm going to write what y equals. Y is equivalent to 4x. I'm going to write 4x inside, and then bring the 5 over. Now notice that there is no y equation at all. So when I go to this line, I just see x's. So x plus 4x is 5x, equaling 5, divide by 5, x equals 1. Now, since we know x is equal to 1, and our equation we use for substitution is y equals 4x, I'm going to use that equation. So y equals 4x. I'm plugging in a1, so y is equal to 4. So your ordered pair is 1, 4. So because of that, since it was a solution point, we know that we are one solution. We are independent. We are consistent. Going on to the next example. Yes, I don't play nice and I like fractions, and since students don't like it, I'm going to show you how to easily get rid of them. So in this equation, we see y equals 3/5 x minus 14, y equals negative 10/3 x plus 45. Remember, this is substitution. The thing I notice is that they both say y equals. Because they both say y equals 2, I'm going to set the equations equal to each other. So I'm going to write 3/5 x minus 14 is equivalent to negative 10/3 x plus 45. You're going to make them equivalent to each other. So here's the thing. You want to get rid of, you don't like working with fractions, so get rid of them. First thing I notice, I'm going to circle my denominators. Those are the only two that have fractions. I have a 5 and a 3. I'm going to look for an LCD, which is the least common denominator. 5 and 3 are both factors of the number 15. So in order to get rid of the fractions, you are going to multiply every piece of our equation by 15. So I'm going to write 15 3/5 with an x minus 15 times 14 equals 15 times negative 10/3 with an x, and then 15 times 45. Obviously, I'm going to use a graphing calculator just so I can get to the calculation portion. We're going to eliminate fraction places. So now notice this. You're going to do 15 times 3. That is 45 over 5. I multiplied my numerators and just dragged my denominator over. 15 times 14 results in 210. 15 times negative 10 is negative 150. Bring the 3 over with an x. 15 times 45 is 675. Notice I didn't reduce my fractions yet. All I wanted to do was multiply my numerator so I can get rid of them first. So now we're going to see our elimination. 45 divided by 5, that is 9x minus 210. 150 divided by 3 is negative 50 with an x plus 675. Now to continue the problem, you want your x's together and then your components, your common numbers together. So first thing I'm going to do is I'm going to add 50x to the right. So we get 59x minus 210 equaling 675. I'm going to add 210 to the right. So we get 59x equals 675 plus 210 is 885, which then we divide by 59. So x is equal to 15. So we know what our x value is. You need to find your y value. So in this point, you need to choose one or the other. It does not matter which one. So I'm going to go with the first one. So I'm going to use the first equation. So y equals 3/5 x minus 14. And we're going to do the same thing, only now we're replacing x with a 15. So 3/5, I'm going to write 15 minus 14. Again, multiply just the numerator. So I get 45 over 5 minus 14. 45 divided by 5 is a 9 minus 14. I had $9 but spent 14. I am short 5. So our ordered pairs are positive 15, negative 5. Moving on to our next example. In the previous examples, we were using the y's for substitution purposes. And this example we see is as x equals 3y plus 5, and then negative 5x plus 15y equal to negative 25. Since they already say x equals, I'm taking the first equation, I'm substituting in the second equation. So I'm going to write our equation. Negative 5x plus 15y equaling negative 25. And I'm going to substitute 3y plus 5 in for x. So I'm going to write negative 5, and then I'm going to put parentheses because I need to replace the x with 3y plus 5. Bring down your 15y and your negative 25. You're going to distribute. So negative 5 and 3 is negative 15y. Negative 5 and positive 5 is negative 25. 15y slides down. Negative 25 slides down. Order of operation requires you to combine like terms. So the thing I notice is I'm short 15y and I found 15y. They cancel out, leaving you with negative 25 on the left equaling negative 25 on the right. They left and right side balance, which means we have infinite solutions, which means it's consistent, but they are dependent. So for our solution values, you're going to put in lowercase double O's to represent infinite solution values. Moving on to our next example. So word problems are a big component of mathematics. In this instance, first thing I do, let's read our sentence. It says one number is 1 less than a second number. Twice the second number is 25 less than 5 times the first. Find the two numbers. They want the smaller number and then the larger number. So let's write our statement down. One number is 1 less than a second number. That's my first statement. The second one says twice the second is 25 less than 5 times the first. So first thing we're going to do is pick values to represent a key. So I'm going to say that the first number is x, and then the second number is represented by y. So first thing, always think of order values, so x and y. The first one says one number is 1 less than a second number. So when it says the word less than, that is a switch. They switch positions. So if you see the word less than, greater than, or more than, what comes first goes second. What was second comes first. So it says one number is, and you see the word is, that is representative of the equal sign. It says one number is. So I'm going to say x is 1 less than a second. So the second number is y minus 1. So I did one number is, so x is equal to y minus 1. That's what we came up with. It says twice the second number. In this instance, the second number is y. Twice means 2 times. So we have 2y. There's the word is equal to 25. There's that phrase, less than 5 times the first. The first number was x, so 5x minus 25. So we have 2 equations. X is equivalent to y minus 1, and then 2y equals 5x minus 25. Since this says x equals, I'm going to use substitution, substitute the x equation into the second equation. So 2y equals 5x minus 25. I'm plugging in y minus 1 for the x value. So 2y, 5 times y minus 1 minus 25. We're distributing. So 5 and y is 5y. 5 and negative 1 is negative 5 minus 25. You're going to combine like terms. So 2y, 5y. Short 5, short 25, I'm short 30. Subtract 5y back. Short 3y equaling negative 30. So a number times negative 3 gives you negative 30. When you divide both sides by 3, y is equal to negative 10. So there's our y component. Then it says x equals, remember we want to find our x value. So x equals y minus 1. So x equals negative 10 minus 1. So x equals negative 11. So negative 10 and negative 11. Now here's the thing. It says the smaller number. Think of, because our values are both negative, on a number line, here's negative 10, here's negative 11. Smaller means it's going further more negatively. So since negative 11 is more negative, negative 11 is a smaller value. The larger number is one approaching 0. Since negative 10 is closer to 0, our larger number is negative 10. Moving on to our next and last example for this section. Okay, it's another word problem. It says in 1 year, Michael earned $6,300 as a work study in college. He invested part of the money at 9% and the rest at 7%. If he received a total of $493 in interest at the end of the year, how much was invested at 7%? How much was invested in 9%? These type of problems, when I like to teach them, is I use a chart. So first thing I notice is they tell you he earned that total. That was how much he earned in total. He invested at 9% and 7%. And he earned $493 in interest. And they want to know how much he invested at each of them. So this is an I equals PRT, interest equals principal rate times time. Since they gave us values, let's look at our chart value. So we have a 9% as a header. We have a 7% as a header. We have total. This is going to be the accounts, and this is going to be your interest. Now, you need to come up with units. So I'm going to say the X is going to be the 9% account, and Y is going to be the 7% account. So they didn't tell you how much they invested. So 9% is X, 7% is Y. Total, they told you the total amount invested is $6,300. So that's where the $6,300 goes. Interest. That they told you the interest of account X is 9%. So you are going to multiply in decimal form downward. So 9% is saying 0.09 and attach an X. 7% is 0.07 and attach a Y. And they told you the total amount of interest. It was $493, so $493 goes here. So when we look at our equations, we have 2 equations. Because remember, you're adding the parts. So the sum of these is going to equal this. Since we have two accounts, we're adding the sum together to give us our total value. So we see x plus y equals 6,300. 0.09x plus 0.07y equals 493. We're going to take one equation and plug into the other. So I'm going to take the first equation and get rid of the y. So I'm just subtracting y over. So I'm saying x is the same as 6,300 minus y. And this is what I'm using for substitution. So I'm taking my equation, 0.09 times 6,300 minus y plus 0.07y equals 493. We're going to distribute. So 0.09 times 6,300 is 567. As I multiplied in. Then we get negative 0.9y plus 0.7y equals 493. We're going to combine like terms right here. So we're 567. I'm short 9 pennies. I found 7 pennies. I'm still short 2 pennies with a y. Subtract the 567 over. So negative 0.2y is equivalent to negative 74. It's okay because we have a negative equaling a negative. When you divide both sides by that negative, it turns positive. So y is equal to 370. We invested $370 at the y value. The y value was the 7%. So 7% was 370. Then they want to know what was in the 9%. Well, let's look at this alphabet technically. What it is x plus y equals 6,300. So x plus y equals 6,300. X we don't know. Y we know is 370. So just take 6,300 and subtract 370. So we invested 5,930 at the 9%.